Hello viewers, welcome to my channel KK Concepts of Electrical Engineering.
Capacitance of coaxial cable. Consider a coaxial cable with inner conductor radius of A and the outer conductor radius of B. The inner conductor is uniformly charged with Rho linear charge density. The outer conductor is grounded. Let V is the voltage between inner and outer conductor. Consider a point R from the origin. Let this be R. Now field intensity E equals to rho L divided by 2 pi epsilon naught rho, where epsilon is the permittivity of the medium between inner and outer conductors. We have taken the rho in cylindrical coordinates. Then the voltage difference between A and B is given by minus integral B to A E d rho, that equals to minus integral B to A rho L divided by 2 pi epsilon rho d rho, which again minus rho L by 2 pi epsilon. When you integrate 1 by rho, you are going to get log rho to the base E with the limits B and A. Then minus rho L by 2 pi epsilon log A minus log B, which in turns rho L by 2 pi epsilon log A by B to the base E, which equals to rho L divided by 2 pi epsilon log B by A to the base E. This is VAB. Now, capacitance for unit length. The C equals to rho L by B. Then rho L by rho L, then 2 pi epsilon is log B by A to the base E. Rho L gets cancelled. C equals to 2 pi epsilon divided by log B by A to the base E farads. Farads per meter. Let epsilon R is the relative permittivity of dielectric, then epsilon equals to epsilon R epsilon naught. Epsilon naught equals to 8.854 into 10 to the power of minus 12 farads per meter. Now substitute this in the capacitance. C equals to 2 pi epsilon R 8.854 into 10 to the power of minus 12 divided by log B by A to the base E. Now when you calculate this, you are going to get 55.63 epsilon R divided by log B by A to the base E picofarads per meter. Now converting the denominator log to the base E into log to the base 10. So we know log b by a to the base e equals to log b by a to the base 10 divided by log e to the base 10, which equals to log b by a to the base 10 divided by 0.4343. Substitute this value in this, then C equals to 55.63 epsilon r divided by log b by a to the base 10 into 0.4343, which equals to 0.02416 epsilon r divided by log b by a to the base 10 nanofarads per meter. This is in to the base e form.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share, and subscribe. Thank you for watching the video. Please stay tuned for more videos.